Hello students, welcome to Smart Learn Chemistry. We are going to learn this topic surface chemistry. This is one of the topics of physical chemistry. Okay, the word is very common, the word is very easy to know. Okay, you know what is a surface, you know what is chemistry. But in chemistry, surface chemistry has a special, the surface word has a special meaning. Okay, I'll tell you what it is. It's basically an interface between two different types of substances. That's what, that is surface. Now understand this, it's an interface between solid and a solid, that's the surface. Interface between a solid and a liquid. Interface between two liquids, provided they are not miscible, non-miscible liquids. Interface between liquid and a gas. Interface between solid and a gas. These are the interface that we are talking about. There is no interface between a gas and a gas, right? Gas and a gas, you don't find an interface. There is no distinct surface between the two gases. So these are the interfaces that we are talking about, right? So let us understand what are the different properties, surface properties. Okay, I'll list them one by one. Here, the first property that we are going to learn here now is adsorption. Adsorption. Okay, I'll tell you the meaning of this. The second property is, say, colloidal property. That is also there in the chapter. And the third one is catalysis. Then there is corrosion. Then there is emulsion. These are all the properties which are basically the surface phenomenon. Surface related properties are listed here. Right? So what we will be learning here in chemistry is how the two surfaces interact. The interaction between the two surfaces. That's the basic thing that we'll be learning. Adsorption is one of them. We start with adsorption, right? So I'll tell you the meaning of this adsorption. Try and understand the meaning. I read the word here. Adsorption. Okay, let me define adsorption. What is adsorption? When it is a phenomenon in which the concentration of one substance is more on the surface of another substance as compared to its concentration in the bulk. That's adsorption. Say for example, you have taken one substance and there is another substance whose concentration on the surface of this substance is much higher as compared to its concentration elsewhere. Right? So it is trying to absorb this another substance on the surface of this substance, right? That's called as adsorption. I'll give you the example, you'll come to know. This one is called as adsorbent, and these words will be using very common in the chapter. And the other substance which sticks onto the adsorbent is called as adsorbate. So you can define adsorbate in your own way. Adsorbate is that substance which is adsorbing on the surface of an adsorbent, right? Fine. So this is called as adsorption, the basic thing. Now let us see where it is used. First of all, I'll give you one example. Say you take a charcoal piece, a solid charcoal, the wood charcoal piece, and put it in a glass of water. When you do that, you'll see that at the bottom of the charcoal, there'll be some colloidal formation. Globules of air will be formed. You'll notice it at the bottom of the charcoal. Now, how this happened? That is because this charcoal has a unique property. It absorbs the gases. Right? So this property can be used. Okay, the charcoal. We can actually go to the uses. I can list them out just one by one. I'll tell you. Charcoal is used for adsorption. Now, where it is used? Many places it is used. Okay. The most common place is gas masks. These are the masks, not the kind of mask which we are using against COVID. These are the masks which are special masks which are used by the miners, the people who work underground for coal mining. Okay, because there are many poisonous gases around. So what happens? These gas masks have got charcoal powder inside. In fact, that powder is activated. I'll tell you the meaning of this also. So that they absorb the poisonous gases and the people are not harmed. They don't go into the lungs, right? So that is what the work is of the charcoal inside gas mask. Now what is the meaning of activation? Activation means I'll tell you what it is. See, you have seen popcorn. You know, everyone knows what is popcorn. This popcorn has a different shape before it is produced. It's basically a kernel of corn. Then you form a popcorn out of it. Okay. Once it is popcorn, then you see it becomes soft. It becomes spongy kind of. How it becomes spongy? Because it gets lots of pores inside. You know, you can make out. You can see that. This is the same kind of process of activation, so that you get micro porosity into charcoal so as to increase the surface area of this charcoal. The example is around 1 gram. If you take charcoal and post activation, the surface area will increase to 3000 meters square. Imagine this. This is the kind of advantage that you get when you have activation of a charcoal. That is why it is used in this kind of processes. Yes, got it? So let's go for the next one. Next is, if you have seen this, this is very common. You buy any item, mobile piece, new mobile piece, you will come along with all your necessary parts. You also get a small pouch of this silica gel. There will be white color granules which is inside, and it will be written very clearly, do not consume. Okay. Then what is the use of this silica gel? It will absorb the gases of moisture, basically moisture around it. This has a special property. It's also, the design is such that it absorbs the gases, right? So that the moisture doesn't harm your eye. You will find this in, say, electronic, this one, instruments, then in the packing, clothes packing, maybe in some food packets. This is very common, silica gel. Okay. Next, coming to another one. It is used, now I tell you where. Because of this charcoal only, I tell you another use. It is used to create high vacuum. I'll write this. What is the meaning of this? Now understand, if you want to create a vacuum in the container, okay, if you pull the air out of it, the container is airtight, the gas will go, but small traces of gas will still remain inside. In order to remove this, you put charcoal, the charcoal inside. Whatever rest remaining gases are there, that will be absorbed on the surface of this charcoal, so that you get 100% vacuum, clear vacuum you will get. Okay, that's another use. Okay, the next use you can get is in curing. In disease curing. What is the meaning of this is that it's very simple. When you consume drugs, okay, those drugs, the particles of the drugs, they go and absorb on the surface of the germ, basically the pathogens. So what happens? This is a germ cell on which these particles of drug are adsorbed, okay, on the surface. So eventually these drug particles attack this germ, and then eventually it kills the germ. So that's why, because it flows through the bloodstream. No, during that process the adsorption takes place, and that way the drug helps in curing the disease. Okay, this is another one. The next one is water purification. Okay, many times water, you must have having the filters in which the activated charcoal is inserted into the water, so that the unnecessary gas are not going into the water, and it is used. Most important, another one which is there in the chapter, that is about heterolytic catalysis. What is heterolytic catalysis? Very simple. If you take a catalyst, the catalyst is something that helps in speeding up the reaction process, right? So if you take a catalyst which is of a different phase as compared to the reactant, the reactants are gases, the catalyst is a liquid or solid but not gas. That is called as heterolytic. The example I'll give you, H2N2, this is Haber's process, which is coming many times in the chapter. That gives you NH3. I'm not balancing it. Here if you are using the catalyst as iron, okay, iron is solid, these are two gases, so you are using this iron to speed up the production of ammonia, right? So this type of catalysis, this plays a role of catalyst in the sense it absorbs these gases and makes the reaction to occur on its surface. That's another important use. So these are the basic uses, right? Now the next type of process that we have to understand, I'll wipe this. Okay, now there is something under adsorption only, I tell you. There is something called as positive adsorption and negative adsorption. I just break this here. Positive adsorption and negative adsorption. Now what is positive adsorption? This is the same thing what we have seen. The listing is all positive adsorption. Then what is negative adsorption? Negative adsorption is like this. When you have a surface and the concentration on the surface of an adsorbent is lesser, where here the concentration is more. I hope you got this. Negative adsorption is when the concentration of adsorbate on the surface of an adsorbent is lesser than its concentration elsewhere. That's called as negative adsorption. Now you'll wonder where it is used. One of the most common example is dilute KCl with blood charcoal. I'll tell you what it means. Okay. If you mix dilute potassium chloride with blood charcoal, then on this blood charcoal surface, KCl will be adsorbed with lesser quantity as compared to its concentration outside, away from it. Hope you followed. With dilute KCl and blood, now blood charcoal is real charcoal of blood, animal blood. Okay, it is made from that. So this adsorption of KCl on this will give you negative adsorption, right? With concentrated KCl, you'll get positive adsorption. With dilute KCl, you get negative adsorption. Now, why it occurs? Why this negative adsorption occurs? This is very simple. Because you are using water in between. You're diluting it. No. These water particles sit on the surface because they are polar. No. They sit on the surface of the charcoal. They don't allow KCl to get adsorbed on the surface of charcoal because the preference is for the water molecules. That is why the concentration of KCl on the surface of charcoal becomes lesser than its concentration outside or even inside. Hope you got this. That's called as negative adsorption. Okay. Okay, this is second term. Now let's understand there is another word called as desorption. And this is exactly opposite to adsorption. Desorption is a process in which the adsorption is reverse, in the sense what? The phenomenon in which the adsorbate is removed from adsorption. That's called as desorption. The removal of adsorbate from the surface of adsorbent. That's called as desorption. This is also used. There are different types of desorption. One is thermal. Now the detail I'm not going. Then there is oxidative. There is reductive. These are the different processes by which the desorption is carried out. Now I'll tell you one common example of desorption. See, you take a glass of water. There is water. By default, there will be adsorption on the surface of this water. Okay, there will be adsorption on the surface of this water. Now this adsorption is automatic because it's a natural process. It happens. Now you take this glass of water outside in the sun. When you take it outside, you will have this these air molecules which are stuck on the surface of this water flying away. They'll escape. Okay, because of the high temperature, they'll escape. That is called as desorption. The concentration is now lowered. That is called as desorption. A simple example, right? Okay. Now coming back to adsorption, I will tell you there is another thing about adsorption is exothermic. This is a very frequently asked question. Adsorption is exothermic. I'll explain this concept to you. Why is adsorption exothermic? Now if you go to see what is adsorption, we can understand properly, then only we'll understand why it is exothermic. Okay. Now this is, say, liquid. There is liquid below this and here there is air. So adsorption is a process which occurs between two different types of phases or the same phases but different matters, right? So what will happen if you take molecule of liquid, say water, let's take about water only. If you take a molecule of this water on the surface of water, this molecule and a molecule here in the bulk of water, there will be a difference between the two in terms of its stability. Okay, now how? This molecule will be pulled by other molecules on all sides in 3 dimensions. three different dimensions on all sides, this molecule will have interactive forces of attraction with the other molecules, right? Now these forces will balance the molecule and as a result keep these molecules stable. It will be stabilized because of balancing. All the forces will nullify. Eventually this one molecule will not have a effective motion, it will stay there. It will have the lowest energy level because all the forces are nullified. Now coming back to this molecule, you will see that there is a force of attraction between this molecule and those below it. Sideways also, but not between this and the top one. There will be another type of molecule which is not water, but interactive forces will be between the bulk of the other molecules and that on the surface. Now if you go to see, now this is prior to adsorption. Okay, this is prior to adsorption. Then the effective force of this molecule acting on this molecule will be coming downwards, right? The effective force will be going downwards. As a result, it will have instability. It will not be stabilized. It is having effective force. Because of which, this fellow will try to get stabilized, reduce its energy. Its energy will be a little bit higher level as compared to this one. So because of that, it will try to acquire stability by absorbing other molecule. So to have stability as well as net effective force to be zero. And if the net effective force becomes zero, its energy level will be zero. In order, because it has got certain energy level now as compared to this, to get it to a stable level which is zero energy level, its excess energy has to be released. When it absorbs another molecule on the surface, this energy is released in the form of heat. Okay, the small portion of energy that is released is in the form of heat. The difference in the energies, that energy which is released is in the form of heat by absorbing other molecule. Clear? That is why adsorption is an exothermic process. I hope you followed this. Okay. Again, you can see the video again, just you will get a proper explanation. Okay. Then try to memorize how it is, why it is called as exothermic. Now this is desorption. Okay. Then under absorption, okay, there is another one called as absorption. And it's a very straightforward word. Okay. But technical meaning is like this. The concentration of adsorbate inside an adsorbent is uniform. It is not high on the surface, low on the surface. It is uniform throughout the bulk. That's it. And that is called as adsorption. So you take this chalk, dip it into ink. You will see initially it is adsorbing because only the outside portion will become blue color, say blue ink, so blue color. After some time, as the ink penetrates inside the body of this chalk, you will see that it has fully absorbed the ink, and then you will get the full absorption of the gas of the ink inside the charcoal, right? So that is called as absorption. It's a simple phenomenon wherein the adsorbate is a uniform concentration inside an adsorbent. Clear? That's a basic difference between adsorption and absorption. Okay, now coming back to adsorption once again. There are two types of adsorptions which are listed in the chapter, and that physisorption and chemisorption. The words also are very clear, the meaning is very clear. So physical adsorption, chemical adsorption. We are talking about adsorption only, but one is physical, one is chemical. Okay, now let us understand what is the basic difference between the two, right? In physical adsorption, first of all, this is no specificity. No specificity. Is it right? Specificity. So it is not specific to particular substance. This one is specific. Specificity. So specificity, right? Okay. So this one is not specific. It's a basic, it's normal sticking of two substances. That's it. Whereas chemical adsorption is actual reaction taking place. So it has to be specific. I mean, you can't have reaction like, for example, helium with iron. You can't have this reaction. You can't have this. So there are certain places where the reaction doesn't occur. So it has to be specific. This type of adsorption is specific. See the two surfaces. In this case, the surface is temporarily bound. Here there is a permanent binding, right? So here you can say that this is reversible. This is not reversible. What does it mean? In this case, adsorption and desorption can occur. Think about this. Adsorption also, desorption also can occur. In this case, desorption cannot occur. Only adsorption will occur. It's not reversible. The chemical bonding has already taken place. No other reverse possible process is not possible. That's why. Third one. This one has got no or less enthalpy of, this consumes less enthalpy of adsorption. This enthalpy is more high, a little higher compared to more. What is enthalpy? You know very well, no? You learned in thermodynamics. I'll not go into the detail. So the enthalpy of this adsorption is lesser. It is given as 20 to 40, I guess, 20 kilojoules per mole to 40 per mole. Here it is 80 kilojoules per mole to 240 kilojoules per mole. Okay, this enthalpy, because it's a chemical process, you need to have a higher enthalpy as compared to this. This is a temporary process, right? Okay, next. This one will have, physical adsorption will have the nature of adsorbate. This is selective to a particular nature of adsorbate, which has, I mean the gases which are highly easily liquefiable, those gases can be easily adsorbed. Meaning is that those gases in which is high, okay, critical temperature is high, only those gases are easily adsorbed. What does it mean? The gases which can be easily liquefiable, like for example sulfur dioxide. Okay, they have given the temperature also. I can just write it here, SO2 630 Kelvin. Okay, methane 190. I'll explain this to you. 190 Kelvin and H2 is there, which is 33 Kelvin. What does it mean is, if you have a gas which can be liquefied easily, those gases can be more easily adsorbed. Those gases which cannot be liquefied so easily, for example SO2 sulfur dioxide, its critical temperature is 630 Kelvin. Means what? Even up to 630 Kelvin the gas can go. Then at that level, till that level, if the temperature rises, till that level also you can liquefy it. Does it mean that this can be easily liquefied? Yes. For this one, for H2, it is only 33 Kelvin. Later on it becomes a gas. You cannot liquefy it more. Hope you're getting this point. That is on that scale only it is adsorbing, meaning SO2 will be easily adsorbed. Here no such case in case of chemisorption. Okay, that's a basic difference. There's another one, few more. In adsorption you have again I'll come to this. Let me write here. In physisorption you have multi-layer. There is multi-layer molecular formation. This I'll tell you how. This is unimolecular. What does it mean? It means what? In physical adsorption, if you increase the pressure, suppose this is a base, this is a substrate. You want to adsorb a gas on this substrate. Okay, this is a solid and there's a gas. You want to adsorb gas on this substrate. What you can do is, okay, it adsorbs. Now you increase the pressure. By increasing pressure, more gases will absorb. Still increase the pressure, more gas is adsorbed. Right? This way you have multi-molecular layer formation on the substrate, on the adsorbent. Here it's a just chemical reaction. There is one substance, there is another substance here, just one reaction, that's it. and then the chemical bonding is taking place, right? In this case, it is unimolecular. Okay. The first difference which I missed, this is due to van der Waals forces of attraction. It is just a temporary, as I told you. The intermolecular attractive forces create a physical adsorption. Here, this is because of actual chemical, ionic or covalent. These are the only forces, right? Chemical bonding. So, this is basically because of that bonding. In this case, it is only van der Waals forces. That's the basic thing. There are 2-3 more. Just tell you. Here, no activation energy. Here, activation energy is needed. This is also the difference, right? Because it's a chemical process, activation energy is needed, right? These are the basic difference of physical adsorption and chemical adsorption. Hope you understood my explanation. Okay, this is Mahesh Toraskar. Keep watching all my videos. Thanks for watching this one. Bye-bye.